Welcome to Homework Lib.
Hi, so in this case what we're going to do is to look at the different resonance structures resulting from the bromination of aniline, which has the following structure. We have our benzene ring, I'm going to put the double bonds over here, and our NH2. So, let's begin first with the resonance structures coming from the ortho bromination. This means that when I attack my nucleophile, in this case the bromine atom, it is going to stay in this position with an hydrogen here, and we're going to get our NH2. In the way that I drew this structure, the positive charge is going to be right below, oops, the positive charge is going to be right below the carbon that is attached to the NH2, and the two different double bonds are going to appear here. So let's draw the different resonance structures. So the first one is going to be, let's just move this pair of electrons to this position, and we get the following. Now we have a double bond over here, NH2, my bromine and my hydrogen atom here as always, and now the positive charge is in this position. The other possible resonance structure is going to be, now let's move this pair of electrons from here to here, and we get these two double bonds. Now the positive charge is going to be in this position, and we have our bromine and hydrogen here, and our NH2 starting on this position. Now I'm going to take advantage of the first drawing that I made in order to generate a different resonance structure, because we know that the nitrogen is going to have an extra pair of electrons that is going to be attached to it that can participate into resonance. So I'm going to redraw that first resonance structure just to make the example clearer and to not overlap with the other two. And what we're going to see is that the pair of electrons of my nitrogen can enter into this position and generate a positive charge into the nitrogen atom. So we end up with nitrogen, hydrogen, hydrogen. The nitrogen is going to be positively charged. We're going to get this double bond towards the benzene ring, bromine, hydrogen. The positive charge here is missing, and now we have these two double bonds. So these are going to be the four different resonance structures that are possible. 1, 2, 3, and 4. Now let's do the same for the metabromination. In the case for metabromination, the bromine atom is going to be in the following position. In this case, we only have 3 possible resonance structures, so it is going to be a little bit easier to deal with. And actually, now the nitrogen, as you're going to see, is not going to be able to participate into resonance. So the structures that we're going to have are the following. Now, if I want my bromine to appear into the meta position, in the way that I drew my original structure, the positive charge would need to be right here, correct? So the 3 possible resonance structures are going to be simply moving electrons from the double bond into different positions. This is the first one. Let me label this section directly as meta, just for sake of completion. And we are going to get the following. Bromine, hydrogen. This double bond stays the same. Positive charge here, NH2. And the final one, we move this pair of electrons right here, and we get, let me go down a little bit further, and erase this line. We get NH2. Now the positive charge is going to be in this carbon atom, and the double bonds appear here and here. So we have bromine, hydrogen, and those are the three possible resonance structures that we're going to look at. And for the final one, which would be the parabromination, the resonance structures are going to look pretty similar to the ones of the ortho one, and we're going to have four as well. So in this case, I'm going to start with the odd one out. In the case where we have the parabromination, right here we're going to have in the para position my bromine and an hydrogen atom. In this case, the positive charge would be in this position, and we have the other two double bonds over here. So now, what is going to happen is the movement of electrons comes from here to here, that generates double bond, double bond. Now the positive charge is in this position, and we have bromine and hydrogen. Down here we have our NH2. And remember that we have this pair of electrons. So the pair of electrons can come right here, generate a double bond, and the nitrogen is going to be able to hold the positive charge from the cation. Now we have the double bond in this position, and our benzene ring is going to have this pair of double bonds. Let me go a little bit down. And remember always bromine and hydrogen down here. Now, the final possible resonance structure is going to be the movement of electrons from the double bond towards this carbon and the nitrogen recovering its lone pair. So what this generates is bromine, hydrogen. Now the positive charge would be in this position, and we have double bonds over here and here. And we recover our NH2 with the lone pair of the nitrogen. So those would be the four resonance structures for the para addition. 1, 2, 3, and 4. With that, it would be all. Thank you very much and have a good one.